Okay, so example number 4. Example number 4. We are going to do sine pi x plus pi, sine x plus pi. Sine was what? Sine, cosine, cosine, give some space here. Sine, and it's x pi, plus, so this is going to be plus, right? Right, is that the correct? Cosine pi is equal to what? Cosine pi
is -1.
-1. Negative sine x. Sine pi.
+1.
+1 would not be correct. It is 0.
I was like, what?
So this is your answer. Okay.
You almost made it sound like a
B. Cosine x plus 3 pi over 2. This is cosine, so it is cosine, cosine, sine, sine, and you're going to put in x 3 pi over 2, x 3 pi over 2. This is positive, which means this guy is negative. Okay. Cosine 3 pi over 2 is?
0.
0.
You're cheating.
Sine 3 pi over 2 is -1. So this is sine x. That's that. Let's go to example number 5. Okay, example number 5 is a little more in depth.
Don't know 1 or 2, but I got 0.3.
Example number 5.
For what?
Assignments.
Oh.
I'll get the last part of the quiz.
Prove the reduction formula of that. So I have tangent theta minus 3 pi over 2. Okay, when Mr. On, you didn't teach us anything about tangent.
Yeah, you did.
Just sine over.
Okay, so the way you're going to work this is going to work this as sine pi over 3, not pi over theta, cosine theta minus 3 pi over 2. Now I can deal with it because I've done sine and cosine both. So this is going to be sine, cosine, cosine, sine, theta 3 pi over 2, theta 3 pi over 2. Since this is negative, this guy's going to be
Positive. Negative.
0.
What? Whoa.
right. In sine, it's negative, it's negative. In cosine, it's the exact opposite, right? Cosine, cosine, sine, sine, theta 3 pi over 2, theta 3 pi over 2. When it's
Positive.
negative.
Yes.
Awesome.
Get it now, Mr. Hunt.
All right. Cosine 3 pi over 2 is?
0. That's what I meant to say.
So this guy obviously going to be 0 too.
Yeah.
Debatable.
-1.
And I don't even care what sine 3 pi over 2 because it's not negative anyway, but they cancel out,
Okay.
right? Because these guys went away, right? These guys went away, so I'm going to have negative cosine theta over sine theta, which is the same as negative cotangent.
Mr. Hunt.
Mhm.
In the book, they wrote out -1.
Well, you can if you want.
Well,
It just
they cancel out.
doesn't matter.
But if they wrote it in, then they'd have to do the calculation,
You can do it.
I guess.
right? Because in the top would be cosine theta and the bottom would be negative sine theta. So it would be between 2 extra steps than I did.
He just made it easier for you. You hate writing out stuff.
All right. So that's example number 5. Let's do example number 6. The last one. Example number 6, express as a sinusoidal form, blah, 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 blah. Okay, so I have 2 sine x plus 5 cosine, what is it? X. Okay. And I'm going to go ahead and express this into a sine bx plus c. Is that what it looks like? Is that what we're trying to do?
Yes.
Okay. So let's find the amplitude first. Remember we did this. Yes, we did
Amplitude is the
this.
first one, so split 2.
Remember we did this? We did this earlier. I said it was like 5 and 1, I believe. And we found that the amplitude was the square root of 26.
Yes.
Remember that? Remember that?
So it's like
So it's the
square
same
root of 29.
thing. Square root of 29, right?
Yeah.
So I'm going to do
What?
25.
And then
I
the
got
square-
it, yeah.
It's
square root of 29 is this squared plus this squared, square rooted. Okay.
Later.
So if you do it this way, I can say that, well, this is what?
5 over square root 29. Oh, that's a hypotenuse, right? Square root 29. 5, 2. Wait. Hey, what are we trying to get here?
Yeah.
Express it as a
Mhm.
sinus.
So we found A. A is going to be equal to the square root of 29.
Plus or minus, right?
No,
No.
just plus. So as long as these two are the same, I'm good to go. Right? What is this? So I'm going to just erase this since we don't need it right now. It's going to be sine bx sine c. Nope, not sine, cosine, right? But it's sine cosine c plus cosine bx sine c. So I'm trying to force this into here, right? What I'm saying, if you look at this, if this guy, because this is just a number, right? And this is just a number, correct? These are the ones that have the variables in it. These are the ones that have the variables in it, right? So if I look at if this guy is the same as this guy, and this guy is the same as this guy, I'm good to go. Right? So in other words, if cosine C was equal to this, right, and sine C was equal to this, I would be good to go. Right? What is B going to be? Obviously, since this is 1 and 1, what is B going to be?
1.
B has to be 1, right? So we just get rid of that. And since that is 1, that is 1, and that is 1.
Then what's X?
No, X is just the
X is X.
X is just X. It's the variable, right? I just need to find this guy. This guy is the guy that I'm trying to find here. I found everything but that. I found A, I found B, I just need to find C,
Yes.
right?
C is
So this has to be this, right? Because this guy has to be equal to this guy. So C is going to be equal to what? Arc cosine. Right? Because it is the angle that gives you this value. Right? The angle that gives me this value. A little tricky.
I'll have to review Yeah,
it's
our
the only
cosine
one,
row.
but it makes sense.
So if you wrote it out in the end, it's going to be A. We found A to be this. Sine B was 1. Then you would add the C. R cosine. That's your answer.
All right.
Done.
Done.
Are we done also?